This is exercise 15.3, calculate earthwork. In this exercise, we will run earthwork for a proposed model with a surface terrain and a subsurface terrain. So let's go ahead and open up that RDWYII corridor DGN file located within the DGN folder of the chapter 15. Once the file loads, let's make sure that the multimodal view is active in the lower left corner. And let's switch back to the open road modeling workflow. And then let's check to make sure the correct files have been referenced. We should have the alignment, survey, and terrain file. And let's make sure that the terrain file is set to active. So now open up the Edit Template Drop tool under Open Roads Modeling, Corridor, and Edits. And then select the Mainline Template Drop. So now we need to make sure that all the left and right cut and fill tie points have the Use Feature Name Override option toggled on. And let's also make sure that the left and right feature override name is set to Construction Limits L and Construction Limit R, respectively. This basically allows the template drop to connect the cut and fill tie lines into one line. So we'll start off with EC cut tie 4 to 1L. So with all these, we want to make sure that the use feature name override is checked, and based on the left and right, have this be construction limit L. And then we just select OK there. So now let's open up the RDWYII existing corridors file located within the chapter 15 subfolder. So now within the existing corridor DGN file, let's make sure we have the correct references attached. So we want to have the alignment, corridor, and terrain references attached. We also want to make sure that the terrain is active. And it is. And it's important to note that this file does contain some complex elements for the existing center line and lines that define the existing EOP using the existing EOP feature definition. All lines were copied from a SS2 survey and then converted to featurized lines. So first thing we need to do here is to create a new corridor along the existing center line, the EXCL. So open the new corridor tool under Open Roads Modeling, Corridors Create, and then within the Create Corridor dialog box, select the Earthwork feature definition. So select the existing center line alignment as the corridor baseline, EXCL. Then right click to use the active profile of that line. And then we can kind of change the name here to Unsuitable Material. And then left click one more time to draw in that corridor. Then within this new Create Template Drop dialog box, select the Lock to Start, Lock to End. Change that drop interval back to 25. And then select the existing EOP plus topsoil template. And this is under Linear Templates, Typical Sections, and then Existing. And then existing EOP plus topsoil. And then click OK. and then we can left click through these prompts. And note that the template placed along this existing center line will be very narrow. And we can scroll in here and see that this is all that it placed throughout the entire corridor. So let's examine that template drop that was just placed. Go ahead and open the Edit Template Drop tool under Open Roads Modeling, Corridors, and Edits, and then select that Earthwork corridor that was just created. Notice that there are 3 lines that follows the surface of the terrain. The red line represents the existing pavement and has a 1-foot depth. The brown line represents topsoil and currently has a 3-inch depth. These can be changed within the component properties. For this exercise, leave the default values as is, and then we can close the Edit Template Drop tool. The existing EOP points in the template are searching for lines with the same feature definition. So go ahead and open the Add Corridor Reference tool under Open Roads Modeling, Corridors Miscellaneous, and the Corridor References. Select the unsuitable material corridor and then select the existing EOP lines. Then right click to close the tool. And do it for the other side as well. And if your file crashed during that step, you can do the next step as an alternative point control method to control the corridor. If your file crashed there, you'd want to do the Create Point Control under Open Roads Modeling, Corridor, Edit, and Edits. And then here you would select the unsuitable material corridor and then set up some of these options. We'll lock to start, lock to end. The point would be the existing EOP L, mode would be horizontal, the control type would be linear, and then the plan element would be the existing EOP L. Then you just go through that to do this step. So once you have this completed, we're going to move on and point control the edge of the topsoil to be removed. So go ahead and open the Create Point Control tool. It's under Open Roads Modeling, Corridor, Edit, and Edits. Select the unsuitable material corridor, and then we can fill in some of the settings here. We want to lock to start, lock to end. Control description is blank. The point here it is BTSR. Mode is both. The control type is linear geometry. Plan element is construction limit R, and that must be selected in the plan view. So I'm going to click through some prompts here. So locate plan view, we need to select the limit control R point, which is all the way out here. Construction limit R. And then continue the left clicks through the prompts. Then we need to repeat that last step to create that point control on the left side. So I just want to be sure to select the corridor again here with my point control tool still open. So select a corridor. The point this time would be TSL. And then we can left click through some prompts. And then this time we need to select the construction limit L. And then finish the left clicks. So now the topsoil should follow the surface to the edge of the cut and fill lines. So now we need to create an existing rock terrain with the assumption that the rock surface is 5 feet below the grade. So let's go ahead and create a new file. And we're going to name this file RDWYII rock surface. Well, this time we need to change our seed to the 3D seed. So browse and then select T.C 3D. And then we can click Save to open and create that file. So go ahead and delete these embedded cells. And then we can attach the RDWYII terrain file. Do so by coincident world. and then hit Fit View to see the entire terrain. So we're going to apply a simple offset of the original terrain to create the top of the rock surface. So open the Create Delta tool under OpenRoads Modeling, Terrain, Create, and then Additional Methods. And here we want to change the Delta method to Terrain Model to Plane. And we want to go ahead and set up the feature definition to be Civil Cell. So under Terrain, Civil Cell. And we're going to name this as Existing Rock. So now on the screen, we're going to locate the first terrain model. This is going to be the only terrain model we have. And the to plane needs to be 5. So it's going to look like nothing happened. But if we scroll in, and we're in a 3D file, so we can rotate our model. And you can see that there's 2 lines now. So basically, the upper one is the existing terrain, and then the one below it is 5 feet below to represent the top of the existing rock. And the triangles are on the new, so go ahead and turn those off if they're not already. So next we need to create a mesh. So open the Create Closed Mesh tool under OpenRoads Modeling, Model Detailing, and 3D Tools. Within the Create Closed Mesh dialog box, we're going to set up the method to be element to depth. The depth is going to be 10. The feature definition needs to be existing rock surface. It's going to be under existing and then existing rock surface. And we'll leave the name as existing rock surface. So now we can left click through prompts. So the first one here is to select the top surface element. So that's going to be the existing rock surface terrain that was just created. So it's going to be the bottom one. And then right click to reset. And the depth is 10, and then select the boundary surface element, which is going to be the offset terrain, so the top. And then right click to accept that, and then left click a couple more times to lock it in. Then we should see some red mesh here. So now we're going to create another new file. So go to File, New, and this file is going to be Road2-EW-Earthwork. But let's be sure to switch back to the 2D seed file. So browse to the t.seed 2D, open, and then we can go ahead and press Save. So as this file loads, it's important to note that we save this file under the Chapter 15 subfolder. This file will be used for the earthwork shapes, which is generally quite large. So due to the size, it is recommended to create the shapes in a separate file so they can be referenced separately from the other models. So within this file, we're going to attach a bunch of files here. We're going to attach the alignments, corridor, existing corridor, rock surface, and then terrain. And we'll do all those by coincident world. And then we'll hit Fit View. So now we need to make sure that the terrain is active, but it's a lot of overlap, so I'm going to turn off the rock surface here. And then we're going to activate this terrain. Then turn on the rock surface level. So now the cut and fill volumes can be run. So open the Create Cut Fill Volumes tool under OpenRoads Modeling, Terrain, Analysis, and then Volumes. So the cut and fill feature definition should already be set. Let's toggle on the Compute Unsuitable and Compute Substrata options. So the cut is cut and fill is fill for feature definitions. And then toggling on these two will calculate the existing pavement and exclude any topsoil from the cut and fill calculations. It also includes the existing rock layer as a separate cut volume, since the existing rock surface feature definition is set to have the substrata volume option. The software will know that the mesh is the substrata. And then we can left click through some prompts. Earthwork will take some time to process, so be patient. So it has finished processing the earthwork. So let's go ahead and open the Open Cross-Section View tool under Open Roads Modeling, Corridors, View, and then Dynamic Sections. And then we can select the corridor. So once you have the cross-section view open, scroll through using the directional arrows at the top of the window, which is the easiest way to view the results in a particular area. So the cut volumes do not include topsoil, whereas the fill volumes do. The earthwork volumes also calculate the cut into the rock section separately from the normal cut section. In addition, the existing pavement volumes was calculated separately to determine what volume will and will not be needed to replace the fill. So it is important to note that ORD runs significantly slower once earthwork shapes have been placed in a file. It is recommended to hold off on running earthwork until the end and not model anything significant with the shapes in the file. If necessary, you can delete the earthwork shapes while making the changes to your model and then rerun the earthwork. To delete the shapes, you will need to select the shapes in the 3D view or the cross-section. If you run earthwork again, the prompt will appear asking if you want to delete the previous results. This means that deleting shapes is not recommended to rerun the earthwork. You can also select the corridors within the file here. So this is the fill volume. You can see that there's this much volume of fill. Same with the cut. This is the cut with this amount of volume of cut. So now the earthwork can be placed into the cross section and an in-area volume report can be created, which can be used for the t.earthwork quantities. So let's go ahead and create another file. So File, New. And we're going to name this file RDWYII-cross-section. But let's change the seed file. We're going to leave it 2D, but we're going to do the 2D seed master file. And then press save and let it load in the file. Let's make sure that we are in the default view. And then let's do the view control plan 3D. Then with the view 1 default active, let's go ahead and attach a few files. Let's attach the alignment, corridor, earthwork, existing corridor, rock surface, and terrain file. All those by coincident world. We're going to open those up and fit view in the default view. And we need to make the terrain as active, so it's easier if we turn off that rock surface so we can easily select our terrain boundary and set that as active. Now let's open the Place Name Boundary tool under Open Roads Modeling, Drawing Production, Name Boundaries, Name Boundaries. Let's select the Civil Cross-Section option at the top. Let's select the drawing seed as cross-section 1010. And then we can select the proposed mainline alignment, which would be OLDR-OP2. We're going to lock to start, lock to end, and do the little arrows here to get to those. And we want to make sure that the Create Drawing box is checked. And then we can left click 3 times here, and then it's going to load. Let it load. You should get a create drawing window. And then everything there should be good by default, so click OK, and then it's going to take a few minutes to process. So by default, the software should open up to the last sheet model. So let's switch back to the default model. And then let's open up the end area volume report. So under Open Roads Modeling, Home, Model Analysis and Reporting, and then Civil Analysis. Then here we want to set the name boundary group to that OLDR OP2, and then just left click and then right click. And then the software will then process the name boundaries. The end area volume report should automatically open within the Bentley Civil Report browser. And then notice that by default the cut and fill volumes are in cubic feet. You can click Tools and then Format Options to toggle on Convert to cubic yards, as well as any other format updates. Then we can close it out, and then next we can annotate the cross sections with a EAV table. So switch to any of the cross-section drawing models. Let's go ahead and open the Annotate Drawing Model tool. So under Open Roads Modeling, Drawing Production, Annotate, and then Drawing Model Annotation. Then within this, we want to select the cross-section EAV table. And then just left click through the prompts. And then you should see the cut and fill volumes on the lower right corner. And then that concludes exercise 15.3, Calculate Earthwork.